Hey everyone, so today we're going to be talking about chapter 8.4, which is talking about trigonometry. So trigonometry is when you have your sides and your angles, and it just is the study, or it talks about the relationship between those side lengths and angles of your triangles. Okay, so something that we are going to learn about is called the trigonometric ratio. So that is a ratio between the lengths of two sides of a right triangle. Okay, so for the purpose of these notes, we will be looking at right triangles and comparing those ratios. So the first ratio we're going to talk about is sine. Okay, so sine is the ratio of a leg that's opposite of the angle and the length of the hypotenuse that is in relation to the triangle. Okay, so the sine of A in this case, if we're looking at angle A, okay, the sine would be opposite. All right, so we're going to look at the opposite side here, opposite over our hypotenuse. Okay, so in this case, A over C. Okay, if we look at the sine of B, right, we're going to go opposite to B over hypotenuse C. So the sine of B would be B over C. Okay, so it's talking about the ratio of those side lengths. For the cosine, we are comparing the ratio of the adjacent leg to the hypotenuse. So again, if we're looking at A, we want the adjacent leg, which is right here, so B over our hypotenuse C. Okay, and then the cosine of B would be our adjacent leg A over C. And then our last comparison, the ratio we have is tangent. Tangent is the ratio of your opposite leg over your adjacent leg. Okay, so this, again, tan of angle A equals opposite, so A over adjacent B. If we look at the tangent of B, we have opposite, which is side B, over adjacent, which is side A, B over A. So the way that you can remember these three trigonometric ratios is going to be by the acronym SOHCAHTOA. SOHCAHTOA, and that's where we are just comparing the things that are involved. So again, with sine, we are going to have the S for sine, opposite over hypotenuse, okay, SOH. Cosine of theta, or cosine of our angle, would be cosine C equals adjacent over hypotenuse, A over H. And then tangent is the opposite over adjacent, or TOA. Okay, so remembering this acronym will help you immensely working through these problems. So working on our first set of example, okay, we have here the sine of P. Okay, so we're going to start off looking at P as our first. Okay, we know that the sine is opposite over hypotenuse. So we're going to go to our opposite side, 15, and then our hypotenuse is 17. Okay, so 15 over 17, and then when we reduce that, or convert it to a decimal, we will have a value of about 0.88. Moving on to our cosine of P. Cosine is going to be the adjacent over hypotenuse, again, because remember, SOHCAHTOA, cosine adjacent hypotenuse. Okay, plugging in those values, we're going to have our adjacent value of 8 over our hypotenuse again, which was 17, and the decimal for that is approximately 0.47. Okay, and then last for P, we have the tangent. Okay, tangent is equal to the opposite over the adjacent. Okay, so opposite was 15. Adjacent is this value of 8. So 15 over 8. which again, if turned into a decimal, we will have a value of 1.88. Okay, and then just for another set of examples, if we're looking at Q, okay, sine again is, well, let's put the angle that we're looking at. So sine of Q equals opposite over hypotenuse. So opposite over hypotenuse. Okay, so opposite is 8 in this case. So 8 over, hypotenuse was 17. Okay, so the decimal for this, for the sine of Q, would be 0.47. Right, now we want the cosine of Q. So cosine is adjacent over hypotenuse, right, or 15 over 17, or again, that is about 0.88. And then last but not least, the tangent of Q, we're going to go opposite over adjacent, okay, or 8 over 17. Oh my goodness. 8 over 17. There we go. My iPad is just messing up. Okay, so 8 over 17 as a decimal is going to be about 0.47. And that is how we find the trigonometric ratios. Okay, so one more thing before we go today. Okay, so we're talking about special right triangles. Remember we learned about these last week, especially the 30, 60, 90. Okay, so we have a 30-degree angle, right? We're wanting to find that tangent. We know that if we are talking about a 30, 60, 90, there are special relationships. Okay, so our short leg can be called x, our long leg is x times the square root of 3, and our hypotenuse is 2 times that length of the short leg. Okay, so if we want the tangent of 30, we know that tangent of any angle is going to be the opposite over adjacent. So we can say that the tangent of 30 degrees would equal the opposite, in this case, which is x, over our adjacent, x square root of 3. All right, our x's will cancel, leaving us with 1 over square root of 3. Now we need to rationalize the denominator. So multiply top and bottom by that radical, which gives us square root of 3 over 3. Okay, and then when we plug this in as a decimal and get that answer, we will have a value of approximately 0.58. So that would be the relationship of the sides in a 30, 60, 90 triangle when you're taking the tangent of the 30 degrees.